Okay, more of homework on section 4.3. This is number 34, and what we want to do is find the relative extrema using the second derivative method or test. So first of all, we do have to find the relative extrema, or it's the critical points. So we'll take the first derivative. So this is y equals x to the fifth minus 80, x plus 100. So the derivative of that would be 5x to the fourth minus 80. And then this is a polynomial. It's not undefined, but it is equal to 0, so or it can be equal to 0, and we can get a value. Add 80 to both sides, divide by 5, get 16, so x is plus or minus 2. So those are my critical numbers. All right? And I can take the second derivative, and the second derivative is going to be just 4 times 5 is... That's going to be 20x to the third. I don't know why I wrote 12. Let me fix that. Doesn't matter because it's going to be 0 either way. I'm making these little faux pas tonight, sorry. Got my trusty white out here. Let me fix that. So let's make that 20. The reason why I use ink is so you can see it a little bit better. Pencil's a little bit light, but then there's always that, you know, you never usually do math in ink. There's a reason for that. So let's say this is 20. Let's let that dry. I'll put the 20 in there. So that's going to be 20. So 20, and that's going to equal 0 when x is 0. Okay, so 4 times 5 is 20. Sorry about that. So we know x is our possible point of inflection. So we can put this in, and we can try this in our second derivative. And it doesn't matter. It's just going to depend on what x is because 20 is going to be positive. If I put the 20 in there now. Okay, there we go. And then again, the sign is going to be inconsequential. Nope, give me that one. This was the 20. Sorry about that. More white up. Okay, we'll fix this up here. There we go. Okay. I think that's good to go. Fortunately, these aren't long problems. Okay. So we've got 20x cubed equals 0. So x equals 0. So if I put a negative, this is just depend on the sign. So when that's negative, it's negative. When it's positive, it's positive. So to the left of 0, it's concave. Down to the right of 0, it's concave up. So this is definitely going to be a relative maximum. This is definitely going to be a relative minimum. Just by looking at the concavity. So what's the value that goes with 2? If I put 2 in my original equation, you can see right over here what you're going to get. Okay. 2 to the fifth is 32, minus 160 plus 100 is negative 28. And if I put negative 2 in here, negative 2 to the fifth is negative 32. Plus 160 plus 100 is, again, positive 228. So these are my points. So I could say that negative 2, 228, so negative 2, 228, is a relative maximum, right up there, because f prime of negative 2 is 0. We found that over here. And it's at a horizontal tangent. And f double prime is negative, which means it's concave down, which means it's a maximum. And then at 2, negative 28, 2, negative 28, okay? This is a relative minimum because f prime of 2 is 0 also as a horizontal tangent. And f double prime is greater than 0, which means it's concave up, which means that's a minimum. Okay? So I hope that is meaningful to you. And then we could look at 39 also. Let's wrap this up here. And again, you could always go back and pause if I'm moving a little bit too fast or you need to check something. You can even zoom in on these. Okay. So this is 39. And they actually give you the derivative. They give you that y prime is equal to x minus 1 squared times x minus 2 squared. And what you want to do on number 39 is you want to find the local maximum, local minimum, and points of inflection. Okay, if it has any of those. Well, we have our critical points, okay? In other words, y prime equals 0 when this is equal to 0. So this is equal to 0 when x is 1 or when x is 2. All right, so I can just put that in. So when x is 1 or when x is 2, this is going to be 0. All right, so these are my critical numbers. And then I can check values of these in this, and if when it's 0, I've got, and that's going to be positive, so that's always going to be positive. So it's just going to depend on the sign of this. If I put 0 in here, 0 minus 2 is negative. If I put 1/2 in here, 1/2 minus 2 is also negative. If I put 3 in here, which is in this range between 2 and infinity, if I put 3 in here, 3 minus 2 is positive. So basically I've got negative, negative, and positive. So what's happening is I don't have a sign change here, so I don't have any relative extrema. Could have maybe a shelf or something like that happening. And over here I do have a sign change. All right. So they ask you about A is where there are any relative maximums. There's no relative maximums, none. But B, there is a relative minimum at x equals 2. Now we don't know what y is because we don't have the original function. So we'll just say at x equals 2 because y prime changes from negative to positive there. So that takes care of the relative extrema. Okay. Then we want to find the points of inflection if there are any, so we have to take the second derivative, so I have to take the derivative of this, and I just had to use the product rule. First times the derivative of the second, which is 1, plus the second, times the derivative of the first, which is 2 times x minus 1. And then out of these two terms here, I can factor out an x minus 1, and what's left is 1x minus 1, because I had x minus 1 squared, plus, and then I took this x minus 1 out, and what's left is 2 times that, which is 2x minus 4. And then I can combine those. X plus 2x is 3x. Negative 1, negative 4 is negative 5. So these are my two factors. Now again, that's not going to be undefined, but it's a nice polynomial, so I can't set it equal to 0. So if I set it equal to 0, it will be equal to 0 when x equals 1 or when x equals 5/3. So we put these down. I was trying to compact this in here, so hopefully you can see it all. Again, you can even zoom in on these, I know, so that hopefully that'll help. So what I did was I did my second derivative test, and I put 1 and 5/3 there, so I tried 0, and you could just check each of these signs and see what you have. If I put 0 in here, this is going to be negative, and if I put 0 in here, that'd be a negative. A negative times a negative is a positive. If I put 3/2, which is between 1 and 5/3, that's 1 and 2/3, so I just tried 3/2. Okay. If I put 3/2 in here, this is going to be positive, and this would be negative, so it's positive times a negative is a negative. Okay. And then if I tried 2, this would be positive, and that would be 6 minus 5 is positive, so that positive times a positive is a positive. So I do have a concavity change here. I didn't write this in. But this is concave up, it's positive. This is concave down, it's negative. And it's concave up, positive. Okay, so you can see concavity changes. So these are points of inflection at x equals 1 and x equals 5/3. Now remember, we don't know what the y is because we don't have the original function. So we just have to give the x value. So I have points of inflection at x equals 1 and x equals 5/3. Why? Because concavity changes there. That's where concavity changes. Okay, so I hope those help.